Since 2012, we have been working in collaboration with our industry partner on a public-funded project to investigate the energy efficiency for data center in tropical environments. Specifically, we have built a modular data center on NTU campus and have opened it to many researchers from all over the world to run their applications on this platform. From our group, we have developed and deployed two applications on this platform. One is the Data Center Lifecycle Management tool that leverages the idea of 3D gamification to provide an intuitive HCI for data center management. The other is a social TV application in which peer viewers can interact among themselves to form content-based communities. One of the terms which often come among our discussions with our collaborators was big data. Indeed, a lot of them are requesting us to provide big data support in our data center platform. As a result, we start to learn about the trend of big data and the technologies that are built for big data. This tutorial paper was prepared as a result of our system building effort at NTU. It has been well documented that data are being generated at a faster speed. For example, 6 billion mobile subscribers are contributing a tremendous amount of data in the popular social networking services. For example, Facebook and Twitter have also generated a lot of data. In fact, a report said that 90% of the world's data has been created in the past 2 years, partially owing to the technology advancement. At the same time, the trend of big data has been featured in leading scientific magazines and public media. For example, Nature and Science both published special issues for big data. The Economics magazine has also published special issues on this topic. So, what on earth is big data? Different stakeholders may have different answers. One main answer is the 4-way, i.e. volume, variety, velocity, and value. Others may say it's Hadoop. Indeed, like the blind man patting an elephant, different aspects of big data mystify the concept. Adam Warney said that big data is like teenager sex. Everyone talks about it. Everyone thinks they know how to do it. Only a few are actually doing it. And those are the ones who are not talking about it, as it will end up getting them in trouble. At NTU, we are a team of researchers who decided to try it by ourselves. Specifically, a team of 4 researchers from Singapore and China devoted more than 16 months of our time to conduct literature survey, have monthly discussion over conference calls, and develop a systematic framework to understand and demystify the concept of big data, and complete this technology tutorial paper for large-scale big data systems. In this tutorial paper, we first surveyed the big data definitions, including attribute definition, comparative definition, and architectural definition, and then reviewed the big data history, and then discussed the big data paradigms, as well as the big data challenges. After that, we present a technology roadmap for big data systems, which pivots on 2 axes, i.e. data value chain and timeline. The data value chain divides the data lifecycle into 4 stages, including data generation, data acquisition, data storage, and data analytics. In each stage, we highlight exemplary technologies over the past 10 years. In the data generation stage, we introduce typical data sources, including business data, networking data, and scientific data. And they introduce a vector of attributes to compare alternative data sources. In the data acquisition stage, we first present the data acquisition mechanisms, then discuss how to transfer data to their data warehouse, and finally, how to conduct data pre-processing. In the data storage stage, we classify them into the infrastructure layer and data management layer. Former covers the data hardware and how to connect them together. The latter discusses file systems, databases, and computing models. For the data analytics, data asset has been touted as the new oil. We brief many data analysis methods, including data mining, statistical analysis, text mining, image retrieval, etc. The objectives of this tutorial paper are multifold. First, for domain experts, we aim to provide them a quick guide to design and implement a big data solution. Second, for big data users, we plan to provide the tools for them to evaluate potential big data solutions for their needs. Finally, for the general audience, we have contracted a professional editing service to increase the readability of this paper, such that they can learn about the basics of big data and its potential impact on our society and lives. It is also one of the reasons why we published this paper on IEEE Access Journal via an open access policy. It is our intention to share what we have learned in the journey of setting up our own big data solution on the modular data center platform at NTU.